This is RD Sharma Solution Class 12 Chapter 13 Derivatives as a Rate Measurer. Exercise is 13.2. The top of the ladder 6 meters long is resting against a vertical wall on a level pavement. When the ladder begins to slide outwards. So this is a wall and this is the ladder. Now this ladder is changing its position. It is coming down from the vertical wall and going on the opposite direction of the horizontal floor. So we have already done this type of question. So this is the length of the ladder which is already given in the question, and this is 6 meters. What about this? Let's take it as x, let's take this as y. And they are asking, the rate is given, they are asking the rate. That means one will be dx by dt, one will be dy by dt. So rate is 0.5 meter per second and it is sliding away from the wall. So dx by dt is given as 0.5 meter per second. So we need to find out possibly the x, which is at certain, how far is the foot from the wall. So x has to be found out when it and the top are moving at the same rate. When dx by dt and dy by dt are both same, then we have to find out, but before that we have to find out dy by dt. So dx by dt is given, dy by dt, that is rate of the y is to be found out, rate of x is given, the rate of change of x, rate of change of y is to be computed. So let us use the Pythagoras theorem, x square plus y square is equal to 6 square. Let us differentiate it. 2x dx by dt plus 2y dy by dt is equal to, this is constant, so it will be 0. It will be 36, but after differentiation it will be 0. So divide everything by 2, you will get x dx by dt plus y dy by dt is equal to 0. So x dy by dt will be equal to negative y dy by dt. Now this x and y has a relationship now, and in the question it is already given dx by dt is equal to 0.5 meter per second. Because it is sliding away from the wall at the rate of 0.5 meter per second. And there are also certain things being given, that is the ladder is 4 meters from the wall. So the x, when it is 4, dx by dt is 0.5 meter per second, and this y, what will be the y? And there is dy by dt which is to be computed. So we need a y also. Okay, if this is 4, this is 6, again we are applying the Pythagoras theorem. So 6 square is equal to x square plus y square. X square is 4 given here, so this will be 36 minus 16, under root of 20 is going to be 4 5s are 20, and 4 5s are 20, so you can take 2 outside, 2 under root. This is 2 root 5. So let us write 2 root 5 here, and dy by dt. So dy by dt is going to be 2 root 5 in the denominator. So if you multiply root 5 numerator denominator, you will get, or you can keep it like that also, minus 1 by root 5 will come. And this is also in meter per second because dx by dt was already in meter per second. So this is the first thing they have asked. The second thing is, when dx by dt and dy by dt are same, that is when the top and the bottom, they are moving at the same rate, then what will be the relationship? So we have x square plus y square equals to 36, we have already used. But in this case, when dx by dt and dy by dt is equal, x equal to minus y. So you can replace x as minus y or y as minus x. It's up to you. Because we are supposed to find out x, so replace x by or y by negative x. So x square plus x square will be 36. 2x square is 36, x square is going to be 18, x will be equal to under root of 18, and 18 is 2 9s are 18. So when you take the root, it will be 3 will come out, 3 root 2. So x will be 3 root 2 meter in this case. A balloon is in the form of right circular cones surmounted by a hemisphere. So this is the diagram. There is a balloon which is, you can call it as a hemisphere right now, and it is the form of a right circular cone. So the cone is the base, having a diameter equal to the height of the cone. So diameter, that is 2r, is equal to height of the cone. H is equal to 2r is our relationship. First thing which we need to know. So when h is 9 centimeter, how fast is the volume changing with respect to its total height? So let me show you and explain the diagram. This is the hemisphere, this is the radius. This whole is r and r will be, 2r will be diameter, and this h, small h is equal to twice of r, which is diameter. What about capital H? Capital H is, assume it to be h plus r. You know, this whole total height of this, say, shape is h plus r. So the height will be equal to h plus r, but h is already equal to 2r. When h is equal to 2r and capital H is equal to h plus r, you can replace h as 2r, you will get capital H as 3r. So you can differentiate it and you can have a relationship. So let us differentiate this, and dh by dt will be equal to thrice of dr by dt. Now height is already given as 9 centimeter. Alright, okay, the question is, certain things are already given, and h is equal to 2r, so you know that you can find out the value of other values also. What is the volume? Just add the volume of this 1 by 3 pi r square h for the below part and 2 by 3 pi r cube for the upper part. Since h is equal to 2r, just replace this h by 2r. 1 by 3 pi r square h in place of h, I am replacing it by 2r. Here also 2 by 3 pi r cube in place of h we have already replaced by 2r. So what do you get? So 3 pi r cube. So 2 by 3 pi r cube, 2 by 3 pi r cube is going to give you 4 by 3 pi r cube. So the volume of the whole shape is going to be 4 by 3 pi r. Now just differentiate it. dy by dt will be equal to 4 pi r cube will be 3r square, and then dr by dt, and there is a 3 in the denominator also. So 3 will get cancelled. But dr by dt is what? dr by dt you can replace it by dh by dt, because how fast is the volume changing with respect to total height? So dv by d capital H we have to find out. So here in this case we have dr by dt is replaced by now dh by dt divided by 3. So what do we got? dh by dt is equal to 3 dr by dt. This already we have done, and we have just done dv by dt as what? 4 pi r square dr by dt. This already we have done. Now we need dv by dh, that is d capital V by d capital H. Not small h. I am writing small h, but it is d capital H, because h we have taken as a small height and capital H is the full height. Now you can cancel these two out. You will get 4 pi r cube by 3. Height is given already. This height is already given, but we have capital H as 3r. This is small h I am writing by mistake, but it is capital H. So 9 equals to 3r, r will be equal to 3. Now put it here. 4 pi 3 square divided by 3, and when you compute this, you are going to get this, and keep it in the with pi on. So it will be 12 pi centimeter cube by second. Water is running into an inverted cone at the rate of pi cubic meters per minute. So it's a volume by time. dv by dt is given. The height of the cone is 10 meters and the radius of its base is 5 meters. How fast the water level is rising when the water stands 7.5 meter below the base? So volume and height. So we have to find out certain thing, that is what is the rate, how fast is the water level is rising. So dh by dt we have to find out. So this is the shape. See, first of all we have the total height is given as 10 meter. Total height is 10 meter. Radius of the base is 5 meter. So just write it as 5 meter. Radius of base is 5 meter. R is 5 meter. How fast the water level is rising when the water stands at 7.5. So total is 10. The upper height is 7.5. What will be the below height? That means up to the height where the water is being filled up. So 10 minus 7.5 is 2.5. So you have volume as 1 by 3 pi r square h, and we need to find out dh by dt. That I already told you. So water level is rising. So from it is right now 2.5. It will go, and dh by dt is to be computed. So h is equal to 2. It is already given. So dv by dt, what will be this case? See, this whole. When we compute this dv by dt, it will be 1 by 3 pi r square h. So you can just write it as h by 2 and you can square it. And then we have 2 by 3 pi, because this comes after the differentiation. dv by dt you have to differentiate. Volume is 1 by 3 pi r square h. You have to differentiate it. I hope you will be able to differentiate it, because one time you have to take r, one time you have to take h. And this h equals to 2r has only come after taking the relationship between h and r. So h by r is 10 by 5, that is, it is r is h by 2. That is why we are able to write this r as h by 2. So now this is already being done. So we have replaced h by 2, r as h by 2, and since h is twice of r, you can have dh by dt as twice of dr by dt. Now you can replace this. Okay, so you can take this pi by 3 outside. dh by dt also you can take outside. So you have h square by 4 plus h square by 2 inside. So you have 1 by 2 plus 1 by 4. So you have this 1 by 2 you can take common, and you have 2 plus 1 by 2. So you have 2. So this is 3 by 4. So finally what we got? Pi h square by 4 dh by dt. This is dv by dt. Volume was 1 by 3 pi r square. You differentiated it when we use the similar triangle, that is h by r is 10 by 5, that is h is 2r, and volume also we differentiate. Okay, dv by dt we have already found out. We are interested in dh by dt. Now dv by dt is already given, as I told you earlier. Water is running into an inverted cone at the rate of pi cubic meter per minute. dv by dt, just place pi. Then you can just bring down things so that they get cancelled out, and finally you can find out dh by dt. So this is 4 by h square, and at what height you have to find out? 2.5. It is already given in the question. So this dh by dt will be 4 divided by 2.5 whole square. That is going to be 0.64 meter per minute. Let me write it here as 0.64 meter per minute. So this is your answer. Okay, 1 by 3 pi r square h, and and the similar triangles. A man 2 meter high walks at a uniform speed of 6 km per hour away from the lamppost 6 meter high. Find the rate at which the length of his shadow increases. So this question we have already done. So I'll just give you a hint because 2-3 questions we have already done. This is 6 lamppost. A person is standing. He is 2 meter. Assume this to be x, this to be y, and we will use this uniform speed 6 km per hour as dx by dt because x is where he is walking, and we'll use the similar triangle. The dx by dt is already given in the question as I just told you. It is 6 km an hour. By the similar triangle, the corresponding sides can have an equal ratio. 6 by 2 is equal to x plus y by this y. So 2 is a 6, 3y is equal to x plus y, and x is going to 2y. Now differentiate dx by dt is equal to twice of dy by dt. As I told you, dx by dt is already with us. It is here 6. This goes down. 2 3 is a 6. dy by dt is 3 km an hour. This is your answer. So I just quickly followed it because we have already done question like this. Surface area of spherical bubble is increasing at the rate of 2 cm square per second. When the radius of the bubble is 6 cm, at what rate is the volume of the bubble increasing? So we have volume, we have surface area. Just assume that you know about this. Surface area is 4 pi r square. Volume is 4 by 3 pi r cube. And this surface area and volume needs to be known to you. So surface area is 4 pi r square. Just differentiate it. ds by dt is 4 pi r square will be 2r dr by dt. So it will be 8 pi r dr by dt. So we'll get dr by dt from here because this ds by dt surface area rate is already given, which is given in the question. It is twice, or not twice, sorry. It's 2 centimeters square per second. So 1 by 8 pi r, and this radius is already given 6, and ds by dt is already known to us. This 2 is already known to us. So you can just have it as, because this is the rate of change of surface area. Now you have 2 divided by 8 pi 6. When you solve it, you'll get 1 by 24 pi centimeter per second. This is dr by dt. Now the second part is volume. Volume is 4 by 3 pi r. Now what is the rate of volume of the bubble increasing? So volume is dv by dt. It's 4 by 3 pi 3r square, and then dr by dt, and again dr by dt is known to us. Radius is also known to us. So just dr by dt is just computed 1 by 24 pi, and at 6 centimeter radius is already given 6 into 6. So you have this you can cancel. 6 4 is 24, 4 gets cancelled. You are left only with 6 centimeter cube per second. This is dv by dt, rate of change of volume. Alright. This question will be taken in the next discussion. Till then, thank you so much. Take care of yourself.